Yeah, first of all, thanks a lot to our speakers for giving these fascinating talks. What we're trying to do today is give you an insight into the many different facets that research are enabling. You saw fundamental research, you saw the applications through cancer therapy. And to wrap things up, I would like to give you just a brief overview of what we have done over more than the past decade to accelerate researcher careers, and I think maybe in the future also your careers here in the audience. One of the most famous scientists of all times is Marie Curie. She is a role model in many different aspects. She is the only scientist to ever win the Nobel Prize in 2 different disciplines. At the time when she decided to study, it was not common practice at all that girls would study a scientific subject or indeed study at all at university, and she had to fight her way through. The same was true when she decided to do a PhD, which she actually could not do in her home country, Poland, and she had to go to France in order to do the PhD there. The next challenge was to get an academic post, which again turned out to be a real battle, which she did, and she became academic staff at a university. And throughout her life, she has really set an example of being a scientist and of being a role model that stands also for international collaboration and success. Now, there is a program by the European Union that bears her name, the Marie Skłodowska-Curie Actions. It's a training program for researchers from all over the world, in fact, and at all career stages. So once you go to university and then you want to go for an international career, the Marie Curie Actions can help you to go into a different country, to carry out the research that you like to do, to gain a very broad range of different skills, and then to boost your employability afterwards. In fact, many of the researchers that are here today and that will be working with you in just a few minutes when we go to the hand-on scientific demonstrations where you can really get your hands into different setups and do science yourself, they are on these Marie Curie programs, and they have changed country. They come from all over the world, and I really invite you to talk to them and find out what encouraged them to go into science and engineering in the first place. Now we, and that means the research organizations that are organizing this day today, we have started going into this area of researcher training more than 10 years ago with a project called DITANET. The idea was that we are looking into ways of diagnosing charged particle beams. Electrons, protons, heavy ions, no matter what kind of beams you would give us, we wanted to measure these beams better than anyone else before. And we wanted to use this to train the next generation of experts in beam diagnostics, and we wanted to do that without any restrictions in their future career paths. So what we brought together was universities that bring the academic ideas, the craziness, the new innovative thinking, industry that pulled them down to earth to make sure that they all stay realistic, but then also large-scale research facilities that have these big accelerators where you can do these studies. It was an exceptionally successful project that trained more than 20 researchers at the time. We carried on and we decided to bring different communities together, and we brought together the laser and the accelerator communities. An accelerator uses a radio frequency cavity to generate a very high electric field. A laser uses an optical cavity to use a very powerful photon beam. So there's many similarities between the two. What we did is we brought these communities together, and that's a picture of a school that we organized in France back in 2012. Now at the beginning of the school you had basically the whole class split into 2 cohorts. There were the laser guys and there were the accelerator people. By the end of the week, and that's here, we had brought them together and we have created links that carry on lasting. So we have lots of projects that have originated from this project. LACubeNet was a project into laser applications at accelerators. Alex here has developed this into a passion and also into a career pathway afterwards. And again, these fellows that we had employed at the time, they came from all over the world with an engineering background, a physics background, mathematics, programming, and they all used lasers for their research. At the same time, we had a project that looked into the optimization of large-scale facilities like the Large Hadron Collider at CERN, like light sources, and we had a cohort of students that decided to optimize particle accelerators and just make them better by working together across country borders, across age groups, and across cultural differences. Now, the 2 current projects that we are running and that are organizing the event today, they are also funded by the Marie Curie Actions within the ITN scheme. One is called OMA, OMA, Optimization of Medical Accelerators. And that's the one where you heard already a lot about from Simon and also in Michael's talk about the use of ion beams. One of the things I haven't mentioned is how does a project get its name. OMA is a German word which means grandmother. And the reason for that acronym is that my daughter, who is 14, she looked at our project and she said, well, Daddy, when you have these research projects, what you're always doing is you have all these nice giveaways like pencils, like T-shirts, and they all have the logo. And she loves her grandmother, so she asked me to one day set up a project that has that acronym as a project name so that she can have her grandmother with her all the time. And well, what father would reject that wish from his daughter? So here we go, and the name OMA was born. The other project that's here today has also the name of a girl, and that's AVA, and stands for Accelerators Validating Antimatter Physics. And AVA indeed was a girl that very sadly passed away a few years ago. But and I had the pleasure to meet her in Warrington when she was already very sick. But she was such a brave and enthusiastic and a cheerful girl, even during the times when she had very difficult treatment. And we thought we should set a lasting memory of her by naming the project after her. So that's behind the name AVA when you go and see the setups today. In terms of the many faces of ITNs, you may have seen our poster, which is here on the lectern and also all across the ACC. You see the plasma ball there, which is one of the classical physics experiments that you may have at school, and you see all these different hats. So these are the researchers that are here today and that have put a lot of effort in over the last weeks and months to put together demo setups, new experiments that you can participate in today. They have also prepared posters about their research, and they are here to talk to you about their own careers and why they choose to become a researcher. So use that opportunity to speak to them, find out where they're coming from, why they have decided to go for an academic career, and also find out about their research. Now, one of the points that's very important is that to enable the best research, the world needs to work together. And the Marie Curie program is exceptionally successful because it does exactly that. It brings together different communities, different countries, across different age groups, and makes European researchers and also researchers from outside of Europe work together all the time. Now, why do we organize this here? Liverpool has been key to establishing all of these programs. We have coordinating the programs that you've just seen, as well as the one on big data science. The area here in the northwest of England is also the birthplace of particle accelerators, and that may not be known to everybody, but it's just here down the road where the world's first accelerator for science was established by these three gentlemen here, Rutherford, Cockcroft, and Walton. And it's still today where innovative research into accelerators is done at the Cockcroft Institute, which is at Daresbury campus, named after Cockcroft himself. And that's where we develop the next and the next generation of particle accelerators and their applications. Now, as I said earlier, today we want to now get you into action and work with our researchers, enjoy the setups, help us capture today by sending us your photographs. We will come back here at 2:30 for a prize award for the best tweet. So enjoy the next roughly 2 hours and engage with the researchers and have fun. Thank you.